Good morning. This is SantanuModule1. I'm an instructor for Chemistry 128A, Introductory Organic Chemistry. In this video, we will talk about alkanes and their nomenclature. Alkanes are one kind of hydrocarbons. Hydrocarbons are organic compounds made out of primarily carbon and hydrogen, as the color-coded name suggests. There are three different kinds of hydrocarbons listed on this slide. The first one is ethane, no double bond, no triple bond, only single bonds, and it's a straight chain molecule. The second example is ethylene, an example of an alkene that has double bond. Third example is acetylene. It is a cylindrical molecule with a triple bond. And the fourth example is that of a benzene molecule that has double bond and has a cyclic structure. They belong to aromatic compounds. Next slide talks about more on alkanes. There are three more alkanes drawn here: propane, butane, and pentane. Propane is C3H8, butane has 4 carbon atoms, and pentane has 5 carbon atoms. All these three molecules are drawn using skeletal or stick diagram style, and you will notice that each of the alkanes names ends with the 3-letter acronym ANE that's there as suffix. ANE is borrowed from the word alkane, and it indicates that the molecule is an alkane molecule. Next slide talks more about how to name an alkane. Chemists generally follow a systematic naming system that is called IUPAC, IUPAC, that stands for International Union of Pure and Applied Chemistry. If you look at the molecule at the bottom that I'm circling with the arrow, is not a simple example of a straight chain alkane. It is a pretty complex example of an alkane that has several branches. So how do we name the alkane? The first rule under the IUPAC system tells us to find the longest alkane chain made out of consecutive carbons first. And if you look at the diagram on the right with the highlighted path in dark, bold red color, you will find that's a 9-carbon chain, and that happens to be the longest carbon chain. So that is going to be the parent alkane that this entire molecule is going to be known after. And this particular alkane is called nonane, and we will learn more on the names of other alkanes on the next slide. So this particular molecule is going to be nonane, and then we will have to designate and figure out exactly how to name its side chains. Next slide lists all the alkanes starting with carbon 1 and up to carbon 10 on the left top corner of the table 4.1. And on the right side, few more alkanes are also listed starting with carbon number of carbons 11 all the way to 100. If you look at the left top corner of the table, you will find that carbon 1 is an alkane called methane, carbon 2 ethane, propane, butane, and pentane. You have already seen how they look like in stick diagram. Hexane comes next, heptane, octane, nonane, and decane. So each of the names of these alkanes should be memorized, since when we name a complex alkane down the road, you need to find the parent chain, and most likely the parent chain will be one of these 10 alkanes. Next slide. You can find the longest parent chain, which is something like a trunk of a tree. You can actually find that in more than one ways. And in this example, this particular complex alkane with several branches can be drawn. The parent chain can be drawn in 2 different ways. Which one is correct? The one on the left or one on the right? The one on the left produces 3 smaller side chains or 3 smaller appendages. The one on the right rather produces 2 branches, and one of the 2 branches happens to be a larger branch containing 3 carbons. The correct nomenclature will follow the parent chain, which is drawn on the left side with smaller but larger number of branches. So that's another rule that we are learning. Next slide talks a little bit more about naming the main parent chain and the side chains. How do we name the side chains, and how do you organize them? So this molecule has 10 carbons in the parent chain, or the trunk, or the main track of the complex railway system, if you want to think about it that way. And you will find that this is highlighted in yellowish white rectangle. The side chains are highlighted in greenish white rectangles, and one of them contains 1 carbon, one contains 2 carbons, and the third branch contains 3 carbons. So if there were separate alkanes, you would call them methane, ethane, and propane. However, since they're part of another molecule and you are looking at them as side chains, you replace the last 3 letters, ANE, with YL to designate that they are actually hanging off of a branch or hanging off of a trunk of a tree. So methane becomes methyl, ethane becomes ethyl, and propane becomes propyl. So ideally, this molecule will be known as, if the order is correct, it is not correct, but if it were correct, it would be called methyl ethyl propyl decane. Realize that the location of the groups could vary. So the methyl group, instead of being here, it could be here or here. The ethyl group, instead of being here, it could be here or here. Therefore, we need to find a more robust system that designates exactly where the groups are. Next slide will teach us a little bit more about learning more on the nomenclature of alkanes. If you have a branch, the branch can also have a branch. So if you have a simple branch that looks like a methyl, ethyl, propyl, butyl group, then that's much easier than handling a situation when the branch can have a branch. And here is an example of a branch having a branch. If it were just a single branch, then it would have been called a butyl group. On top of the butyl group, you have a methyl group. How do you designate the entire side chain which has a branch? You need to number the side chain. Numbering starts from the side of the trunk or the parent alkane chain. So numbering starts 1, 2, 3, 4, not going toward the trunk of the molecule from the end of the substituent. That would be incorrect. So if you do it, if you number the side chain this way, then you have a methyl group on carbon number 2. Therefore, the side chain, the entire side chain will be called 2-methyl-butyl. And there is no space between on either side of the hyphen. So that's the IUPAC way of naming a side chain, a branch side chain. Life can be made a little bit simpler with trivial names for certain side chains which are branched. In this example, on top, you have a parent chain. Off of that, there is a propyl group. If the propyl group, instead of being attached to the main parent molecule from its end, if it is connected to the molecule from its bend, from the middle part, then it starts to look like a V. The letter V kind of slanted, rotated 90 degrees. Whenever you see a V, the word iso or prefix iso is added to the side chain. So this group is going to be called isopropyl. If we had to do the naming following the IUPAC system, it would be called 1-methyl ethyl, longest chain is ethyl, numbering starts from here, ends here. You have a methyl group on carbon number 1, therefore this is going to be 1-methyl ethyl. Another example of a slightly longer side chain, butyl. Butyl can actually stay in 3 more iterations. One where the connectivity is from carbon number 2, and this is called secondary butyl, in short, sec-butyl. You notice that unlike isopropyl, sec-butyl are 2 words separated with a hyphen and the word sec, S-E-C, written in italics. The IUPAC name of this particular group will be 1-methyl-propyl. 2-methyl-propyl is called isobutyl because it's got the V at the end of the side chain. And when the side chain starts to look like a chicken foot but still contains 4 carbons, it's called tertiary butyl or in short, tert-butyl separated with a hyphen, 1,1-dimethyl ethyl. Here we can learn one more little rule of nomenclature of alkanes, where when you have two identical groups on the same carbon, you call it dimethyl. When you have multiple same group, you call it dimethyl, or if you have three of them, you call it trimethyl, so on and so forth. If they're on the same carbon, in order to designate that they're on the same carbon, we write 1,1-dimethyl ethyl. That means both the methyl groups are on the same carbon, number 1. Next slide, one more example. When you have a pentyl group as a side chain, pentyl group can also have the V as a substituent methyl group, and it's called isopentyl, as you would predict. It's also called isoamyl, which is a second trivial name for it. IUPAC nomenclature would call it 3-methyl-butyl group. When you have a chicken foot separated from the parent molecule with a CH2, it's called neopentyl. I never can remember the word neopentyl. And when you cannot remember, you can always fall back on the IUPAC system, which would name it 2,2-dimethylpropyl. What if you have a methyl group on two different parts of the same parent chain? One such example is methylpentane. Methylpentane can exist in 2-methylpentane version or 3-methylpentane version. Therefore, these are going to be called some sort of isomers. How do you number 2-methylpentane? Do you not start numbering from left to right, or you start numbering from right and move to the left? If you did that, this same 2-methylpentane would be called 4-methylpentane. Another example of such controversy could be is shown down here, which is a heptane parent molecule with a methyl group, and this molecule could be called 2-methylheptane or 6-methylheptane. And obviously, 2-methylheptane is correct because you want to get to the branch going in the direction that gets you to the first branch in the fastest possible way. So, and another way to look at it would be to have a smaller integer. If you could call it 2-methylheptane, why would you call it 6-methylheptane? Next example is which direction do you do the numbering? If you have two smaller groups attached to the same carbon, as an example here, and one little guy sitting on carbon number 2, do you think you should number from right to left because that way you get to the bigger branches faster? No. The rule of thumb is you go in that direction that gets you to any branch in the fastest possible route. Next slide. How do you organize the branches? Now we have learned how to name a parent alkane chain, the trunk of the tree. Then you found the branches. You have figured out how to name the branches. How do you organize? How do you place the branches? Is it the smaller group comes first, then the medium group and the large group? That's not correct. We follow an alphabetical order. So once you find out the names of the branches, then you place them according to the alphabetical order. If a prefix has been used, for example, a dimethyl or a triethyl or tetramethyl group is incorporated, then the M of dimethyl is considered for ordering, for alphabetizing the groups. It's not the D of di or T of tri or P of penta that gets considered. Also, if you have a word like sec-butyl or isobutyl, then if it is one word like isobutyl or cyclopentyl, then the I of isobutyl is considered to determine the alphabetical order, not the B of isobutyl. However, when it's a two-word side chain, then you do not consider the S of sec or T of tetra. You look at the first letter of butyl or first letter of pentyl, like P, for figuring out the alphabetical order. So here is the summary of naming alkane molecules. First, you identify parent chain. name the parent chain. You need to memorize all the alkanes with carbon 1 through 10 at least. Name the substituents, identify the substituents and name them in either trivial or IUPAC way, and then number the parent chain in the correct way and assign a locant, exactly where the substituent is situated, and do it the right way. Give the first substituent the lowest number possible, and finally you list all the numbered substituents with a hyphen separating the integer from the word before the parent chain in alphabetical order, and follow the correct alphabetical order when you are organizing the different groups. Follow the rules that you have just learned. Next slide talks about two homework problems. Here is a molecule, an alkane molecule that you need to find the name of. How do you do it? Find the longest chain, identify the side chains, name the side chains, number the parent chain, organize the side chains in the correct order, then you are done. The second example incorporates certain groups that you have not learned in this video. However, if you use your rational analysis capability and common sense, you should be able to figure it out. It incorporates a cycloalkane as a side chain and a cycloalkane as a parent chain, but naming a cycloalkane is quite straightforward. Propane becomes cyclopropane, butane becomes cyclobutane once they're cyclized, and this molecule incorporates a cyclohexane molecule. So the name of this molecule is 1-tert-butyl 2-ethyl 4-methyl 3-cyclopentyl. Cyclopentyl is one word, and it's a side chain, cyclohexane. So draw cyclohexane, number it, and then place the different groups. Thank you very much, and we will see you in the lecture in the near future. Take care. Bye-bye.